This video goes with Unit 10 solutions. The essential questions are: what are the parts of a solution? Why is water called the universal solvent? And what does like dissolve like mean? So let's first talk a little bit about water. Water is pretty important in biology. For instance, living organisms are made up of 70 to 95% of water, depending on which organism we're talking about. Life, including photosynthesis, which is the beginning of the food web, depends on water. And it's the component of many crucial parts to our makeup, like cells and membranes. It's pretty unique. Most substances, for example, have a greater density when it's a solid than when it's a liquid, but if we look at water, it's a little bit different. So here is the typical matter. So gas, it's spread out. Liquid, it's a little bit closer, and solid is really packed. So solid should be the most dense. But we know that ice floats, so that's not true with water. Water's density is greater than ice. So this diagram kind of shows you why the liquid is packed in tighter than the ice. It kind of creates spaces, and that's pretty unusual. So let's talk a little bit about solutions. A solution is a homogeneous mixture. Remember, that means you cannot see the different parts. And it has two parts to it, though. The solute, which is the substance that gets dissolved, and the solvent, which does the dissolving, and usually that's water. So for instance, there's a picture there of a wave. We have salt water. Salt would be the solute. It's getting dissolved, and water is the solvent in that situation. If something is aqueous, that means that water is the solvent. So you could say aqueous salt, and that would be salt water. Okay, if something is a tincture, that means alcohol is the solvent instead of water. So water is an excellent solvent, and it's pretty common to dissolve things because of its polarity. So if you look at a water molecule, we have H2O there. The electrons are not held evenly. The oxygen holds them closer to its core than the hydrogen do, and that makes oxygen a little bit negative and hydrogen a little bit positive. So polarity means electrons are shared unequally, like it has poles. So when salt dissolves in water, the water gets attracted to the negatives and the positives from the NAs and the CLs. You have positive and minus, and so it is able to dissolve things really well because it pulls them apart, kind of like what you're seeing in the diagram there. Okay, so here is also showing you salt and separated, so you have Na and Cl, and those ions are being surrounded by the water. Hydrochloric acid dissolving in water, the hydrogen is a little bit positive, the chlorine is a little bit negative, and so it matches up with the water where the hydrogens are a little bit positive and the oxygen is a little bit negative. Remember, opposites attract, so the positives are lining up with the negatives. So there you go, you have the negative next to the positive, and over here we have the negative next to the positive again. So, like dissolves like, what does that mean? Basically, it's going to tell you that polar is going to mix with other polar molecules, while nonpolar mix with nonpolar. So, for example, oil is nonpolar, water is polar, so they can dissolve different types of substances. If something is miscible, it means two liquids that mix. I kind of remember that it's miscible, kind of sounds the same. For example, water and alcohol can be mixed. Immiscible, which means they cannot mix, would be like water and oil. Those separate out, like the diagram showing you there. So, what types of compounds are going to dissolve in water? We already said water's polar, so it's going to do that. It's also going to do ionic. Salt was the example we used, and salt is an ion. So it's with a metal with a nonmetal. So if you see something with a metal with a nonmetal, that's going to dissolve in water. For example, salt, potassium iodide. Acids, remember we identify acids as being a hydrogen with an anion. So HCl is hydrochloric acid, H2SO4 is sulfuric acid. So they start off with an H. If they're polar, we said like dissolves like, so polar dissolves polar. That's also going to be true. Some examples of that are hydrogen peroxide and ammonia. And any compounds with OH groups at the end, like sugars and alcohols, those are also going to dissolve in water. For instance, ethanol is C2H5OH, so we see that OH group that will dissolve. And glucose, C6H12O6, is a sugar, and that will dissolve as well. Things that don't dissolve in water are nonpolar covalent compounds, like hydrocarbons. So if they just have C's and H's, no oxygens, they're not going to dissolve in water. Okay, those are things like different types of oils. Also symmetrical molecules, they don't like to pull apart very easily, so like carbon tetrachloride. Okay, so now we're going to practice silver nitrate. Does it dissolve or not? That's AgNO3. That would be a metal with a nonmetal, so that's ionic, which means it's soluble. Methanol is CH3OH. I see that OH there, so I know it was a polar covalent, and that means it's soluble. Hydrochloric acid, right away I see acid and I know it's going to be soluble, but hydrochloric acid is HCl. That's an acid, so it's soluble. Potassium iodide is Ki. That's a metal with a nonmetal, so that's ionic, so it will be soluble. And hexane, if we look that up, that's C6H14. I have C's and H's, but no oxygens involved. So that's going to be nonpolar covalent, so that will not dissolve in water. That is insoluble.